All right, so this is Module 7, Homework 1, Rational Functions. We talked about rational functions earlier in the semester. Rational is just a fancy word for fractions. So we're going to be dealing with fractions. I know everyone's favorite.
It's like a pizza pie.
Okay. And expressions. So we are going to identify rational expressions. We're going to simplify them, we're going to multiply with them, and we're going to divide with them. So before we simplify, multiply, and divide, let's go ahead and go back, kind of like old school, and let's make sure we have our foundational fraction skills, our foundational rational expression skills down. So let's do a little fraction review. Let's simplify. Before we even look at this first example, what is fractions? What operation does a fraction mean? Add, subtract, multiply, or divide?
Divide.
Divide, perfect. So if we have 0 over 5, that's really like 0 divided by 5, which is? 0. If we have 3 over 0, 3 divided by 0?
0.
Undefined.
Undefined, good. Put it in your calculator. 3 divided by 0, what does your calculator say? 3 divided by 0, what does your calculator say?
Undefined.
Error. It says error. So that's telling us right there it's undefined. We cannot divide by 0. And lastly, 6 divided by 8. We have 18. Sorry. 6 divided by 18. We have 6/18. So
1/3.
1/3. How did you get that?
18 can't divide into 6.
Okay. So we see that up top and on the bottom, they both have that factor of 6 in common, right? So that means I can factor or take out that common factor of 6. Factoring, remember, means divide. So I can divide out a 6 from the top and the bottom. Kind of like GCF. We're taking out the GCF, just like we did before. 6 divided by 6 on top is left over with 1. On the bottom, 18 divided by 6, we're left over with 3. Boom, 1/3 is our final answer. So a rational expression can be written as the quotient of p divided by q of two polynomials. So the big thing here is a rational expression, a fraction, is the quotient, which means divide. So let's touch on one other thing. I want to make a quick little note. So when we have 6/18, we took out the GCF. We took out the common factor. So let's just kind of rewrite this over here as a quick little note. So 6 over 18, we said was 6 times 1, all over 6 times 3. So that means that common factor of 6 canceled out. Why are we allowed to do that? Just because it's a math magic. No.
They're the same number. It's right the same
It's the same number, right? So what is 6 divided by 6?
1.
1. So it's a fancy way of writing 1. 1 times 1/3 is still 1/3. So that's why we can cancel out common factors. Awesome. Cancel out common factors. Canceling out common factors. All right, so next example, let's simplify the rational expression. What can we cancel and what can we not cancel? If we have x plus 3 times x plus 2 all over x plus 5 times x plus 3, what common factor do they have?
X plus 3.
X plus 3, so those can cancel out. What's left over up top?
X plus 2.
X plus 2 all over x plus 5. Can anything else be canceled?
No.
No, why not?
Because they're not like terms.
Because they're not like terms. They're not the same factor. So even though there's both x, our factor is x plus 2 and our factor is x plus 5. They're not the same factor, so we cannot cancel those out. Boom, we're done. So we can only cancel out factors.
I like how that's a note at the bottom.
Nope. Super important. We can only cancel out common factors. What questions, comments, or concerns do you have for me, please? All right, next one.
Okay.
It's hot here. All right, so simplify the rational expression, simplifying the fraction x plus 3 times x plus 2 all over x plus 2 times x plus 5 times x plus 3. Help me out. What factors can cancel out?
X plus 3.
Yeah, so x plus 3 on top and the bottom. X plus 3 divided by x plus 3 is 1, so they can be canceled out. What else?
X plus 2.
X plus 2 on top and the bottom. X plus 2 divided by x plus 2 is 1. So what's left over up top?
1.
1. Nice, because remember, x divided by 3 divided by x plus 3 divided by x plus 3 is 1. So it's simplified down to 1. So 1's left over up top. What's left over on the bottom? X plus 5. So our final answer is 1 over x plus 5. Okay, good so far, good so far. Uh-oh. So, simplify the rational expression 7y minus 21 all over 5y minus 15. Only difference here is on the previous ones, they factored for us. Now we have to factor. After last test, we should be good at factoring. If you're not good at factoring, you better get good at factoring. Please email me, go to the ASC lab, whatever, because we have to factor a lot. Yeah, we have plenty of people to help us factor. All right, ready? So 7y minus 21. We need to factor that. Our first step in factoring is GCF. 7. Factoring out that 7, we're left over with
7 or y minus 3.
y minus 3. On the bottom, 5y minus 15, GCF.
5.
5 we're left over with
Y minus 3.
y minus 3. So I have 7 times y minus 3 all over 5 times y minus 3. What factors cancel out?
Y minus 3.
Y minus 3. So we're left over with our final answer of 7 over 5. 7 divided by 5. So 7 fifths, they have no factors in common. Final answer. So each step, taking a little further and a little further. Same thing for the next one. Simplify the rational expression. X squared minus 3x plus 2 all over x minus 1.
X minus 1 and x plus minus 2.
Perfect. So that means we have to factor the top first, right? So factoring x squared minus 3x plus 2. GCF.
X.
Oh, you're so ahead of me. So no GCF so far. No GCF so far. Of x squared minus 3x plus 2.
We're going to put that in our check.
So same thing, A is 1, B is negative 3, and our C value is 2. So we're looking for two numbers that will multiply together to give us A times C, so 1 times 2. And the same, which is 2, and the same two numbers to add together to give me negative 3, which is B.
Negative 1 and negative 2.
Negative 1 and negative 2, perfect, thank you. So negative 1 times negative 2 is positive 2. Negative 1 plus negative 2 is negative 3. Because A is 1, thankfully we can go straight to our factors of x minus 1 times x minus 2. So we factor the top, the numerator, into x minus 1 times x minus 2. All over x minus 1. There's no GCF, so nothing can be factored. Just x minus 1. So now we have x minus 1 times x minus 2 all over x minus 1.
X minus 1.
X minus 1's cancel out. What's left over up top?
X minus 2 over 1.
X minus 2 over 1, which is
X minus 2.
just x minus 2. Boom. What questions, comments, or concerns do you have for me, please? Next one, simplify the rational expression. X minus 8 all over 8 minus x. So they look similar, right?
But they're different.
But they're different. Good, they're switched around. So let's write it in the same order first. So x minus 8 all over, the x is negative, so negative x. The 8 is positive, so plus 8. I just wrote them in the same order, so that way now we're comparing apples to apples. What do you notice? What's different about them?
It's fine.
The sign. So going back to last test and factoring, what did we do to make something like this look the same?
Factor out -1.
We factored out a -1. So on the top, if we have x minus 8, on the bottom, if we factor out that -1, we're left over with positive x minus 8. So taking a skill that we used a lot last test and applying it now. Now x minus 8 divided by x minus 8 can cancel each other out. What's left over up top? 1. What's left over on the bottom?
-1.
-1. What is 1 divided by -1?
-1.
-1. Final answer.
Now, would it matter which one we took the -1 out of?
No. So if you took the -1 out of the top, by the way, he asked, does it matter which one you took the negative out of? No, it doesn't matter because if you took the negative out of the top, you'd still be left with the same answer in the end. Great question. Other questions? All right, let's look at this next one. They always like to throw these in there because they always like to trick us. Let's look at the next one. So simplify the rational expression, x plus 6 all over 6 minus x. Looks very similar. Let's do the same concept. So x plus 6 all over negative x plus 6. Notice my x is negative, my 6 is positive.
I'll take constant -1 for this one
Why? You're right. Why? We can't.
because it will change the sign of the 6.
Bingo. Okay, so let's say if we factor out that negative for this one, x plus 6 is going to stay the same up top. Factoring out that -1 on the bottom, that'll leave us with x minus 6. Either way, we can't make them the same. So it cannot be simplified. So whether we leave it like this, whether we leave it like this, whether we leave it like this, it cannot be simplified. So this is in simplest form.
Wait, why can't you put the negative?
So if we took the negative out on the bottom, but now they're still not the same. X plus 6, x minus 6, they're still not the same. So I still can't cancel anything.
Oh, okay.
So because I can't cancel anything, either one of those are equally simple. So it doesn't matter which one you put as the answer.
I have a feeling that we're going to use the square root property in the next one.
You have a correct feeling. Questions, comments, concerns? This one's tricky, that's why I wanted to include it. Questions, comments, concerns? Ready for the next one?
Sure.
Sure. So on the top, last two simplifying examples. Simplify the rational expression x squared minus 49 all over 7 minus x. So let's factor the top, factor the bottom, and then go from there. So what do you notice about x squared minus 49?
That's the square root property.
Perfect. It's the difference of two squares, right? Difference of squares. So that means we can factor this one pretty simply.
X minus
It's
7.
simply a word, yeah. So x squared is x times x. One's positive, one's negative. 49 is 7 and 7. All right, so the top is done. X plus 7, x minus 7. On the bottom, let's go ahead and flip that around like we did earlier to see what's going on there. So that way we're comparing apples to apples. So negative 7 minus x, flipping it around, we have negative x plus 7.
You got your -1.
Let's take out a -1 on the bottom. So we have up top x plus 7, x minus 7. Let's factor out a -1 on the bottom, and we're left over with x minus 7. Perfect, because now our x minus 7s cancel each other out. On the top, we're left over with x plus 7. On the bottom, we're left over with -1. Good so far?
Are we gonna have to rewrite it, like distribute the -1 in because the negative is technically gonna be out front now?
Kind of, yeah, yes and no. So, so remember going back to the very first day of class, which seems like forever ago, we took that negative and we said because it's a fraction, the negative can go on the bottom, it can go on the top, or it can go out front. So let's put it up top with the rest of the x plus 7s. Now it's over +1, so now I can just get rid of that whole fraction and say negative x plus 7. So this is fine, or if you want to distribute it out and say negative x minus 7, that's fine too, whatever one you like better.
Okay.
Either one will be okay in my math lab.
It will be?
Yes, sir. Either one are equally simple. How could I help you understand this one better? Last simplifying example, it says to simplify the rational expression 2x squared minus 13x minus 7 all over x squared minus 10x plus 21. So same thing, factor the top, factor the bottom. Once they're factored, see what factors can cancel. It's just a lot of putting it all together. So let's go for it. So factoring 2x squared minus 13x minus 7. Is there GCF? Nope. So no GCF. Our A value is 2. B is negative 13. C is negative 7. So we're looking for two numbers that multiply together to give us A times C, which is negative 14. And the same two numbers to add together to give us B, which is negative 13.
14 and 1.
14 and 1. So negative 14, positive 1. Negative 14 times positive 1 is negative 14. Negative 14 plus 1 is negative 13. Unfortunately, because A is 2, A is not 1, so we have to go through and factor by grouping. So 2x squared. Instead of our negative 13x, we're going to split it up using the numbers in our blanks. So minus 14x plus 1x minus 7. If you notice, this section is not about factoring. We spent all last section on factoring. So that's why I'm just rolling through this, because we need to focus on stuff that's for this section. So now we have factor by grouping. I can group the first two, group the last two. Looking at our first two terms, 2x squared minus 14x. 2x. Will be our GCF coming out front. And we're left over with x minus 7. Looking at our next two terms, we have x minus 7. We want x minus 7 to be left over. So I have to factor out something. I'm going to factor out a GCF of positive 1. And I'll be left with x minus 7. We know we did something right because I have 2x times x minus 7 plus 1 times x minus 7. So x minus 7 we know is going to be one factor.
2x plus 1.
And 2x plus 1 will be our other factor. So up top, we factored x squared, 2x squared minus 13x minus 7 into x minus 7 times 2x plus 1. Halfway done. I know these are just a little long. So doing the same thing and factoring the bottom now. So factoring x squared minus 10x plus 21. Again, there's no GCF. This one will be a little bit easier though because A is 1, B is negative 10, C is 21. So two numbers that can multiply together to give me A times C, which is 21.
3 and 10. 3 and 7.
Perfect. And the same two numbers to add together to give me negative 10, which is B. So negative 3 and negative 7.
Yes, ma'am.
Perfect. So negative 3 times negative 7 is positive 21. Negative 3 plus negative 7 is negative 10. Because A is 1, I can now go straight to my factors of x minus 3 times x minus 7. Putting it all together, we have x minus 7 times 2x plus 1 all over x minus 3 times x minus 7. That's the hard part, and that's all just from last section, last test. So that should be the easy part. But now, this is for this section. Now we just cancel stuff out. This is my favorite part. It's so stress relieving. Ready? Boom, boom, done, they go away. Up top, boom, boom. We're left over with 2x plus 1. On the bottom, we're left over with x minus 3. These are not the same thing. They're not the same factor, so nothing else can cancel. Final answer, 2x plus 1 all over x minus 3. So that's simplifying. We're going to simplify every single fraction, so we're going to use this skill for all of this. How could I help you understand it better? Decent. We're good? Yeah, I mean, the hardest part is factoring that we did for so long. I won't say it, sorry. All right, multiplying rational expressions. We are going to do the same thing about having a little fraction review. So whenever you multiply and simplify fractions, we're going to go straight across. We multiply straight across. So multiplying straight across, 1/4 times 2/3. So 1 times 2, 2, all over 4 times 3, 12, 2 over 12. What do 2 and 12, what factors do they have in common?
1, 6.
Good, so they both have a 2 in common that can factor out on the top and the bottom, and we're left over with our final simplified answer of 1 over 6.
And that method is directly going to help in the next one.
Yes, so same thing for everything. Straight across, but we're going to factor.
Afterwards?
No, we're factoring first. Because
And then multiply.
yes.
Oh, super.
So leave everything in factored form.
Okay.
Don't ever, it's too much work, don't distribute it. Okay. So next example, multiply and simplify. 40x minus 24 all over 5 times 10 all over 3 minus 5x. So looking at this, let's go ahead and kind of factor while we're here. So looking at our first term, 40x minus 24. GCF.
4.
More. Greatest common factor.
8.
8. Factoring out an 8. What's left over? Oops. I forgot my 5. Factoring out the 8, we're left over with 5x minus 3. 10 is just 10. 5 is just 5. 3 minus 5x.
Nothing.
No GCF.
Can we go ahead and factor out the -1 if we wanted to?
Okay, so let's go ahead. It looks very similar to this other factor of 5x minus 3, right? So let's go ahead and see if that'll work. Let's flip it around first. So negative 5x plus 3. Taking out that -1, we're left over with positive 5x minus 3. So do you see how I kind of, while it was in like 4 separate parts, I went ahead and just simplified and factored those 4 little parts. So now that they're factored, let's multiply across.
I have a question.
Okay, go for it.
Can we, since it is the bit, like we are going to mention something like, do we have to multiply it across? Like, could we just
You can
go
simplify
ahead and
now if you
take out
want.
the 5x minus 3 from both?
Yeah, go for it. Yeah.
That will still work?
Yeah, I'm just kind of like writing it out more, but if you can see it from now, that's totally fine.
Okay.
Yeah, go for it.
Do
Yeah.
you leave the 8 there when we write it again?
Yes. So I'm just going to kind of rewrite it nicer because it kind of looks like everything's all over. I'm just going to rewrite it nicer. That's really all I'm doing. So 8 times 5x minus 3, multiplying across times 10, all over 5 times -1 times 5x minus 3. So I just multiplied straight across, putting all of my factors. Remember, I'm multiplying everything. That's why I put the little multiplication symbol just to kind of make it look neater, to kind of help me. So now looking at this, what factors can cancel?
5x minus 3.
5x minus 3. What else do you see?
We could go ahead and take the 5 and 10, reduce it down to 2.
Perfect. So I can take out a 5 on the top and the bottom, and we're left with 2 up top and 1 on the bottom. So now multiplying across, 8 was left over and 2 is left over up top. If you want to go ahead and write 16, go for it. I'm just kind of,
Oh, sorry.
yeah, no, you're good. All over 1 times negative 1 will give us 16 all over negative 1. So 16 divided by negative 1, negative 16. So yeah, so you guys know me that I know I like to write everything out because I don't like to, if I skip steps, I will mess it up in my head.
No, it's true, because that's how I do it on the test. Like,
Good, yeah.
Like you would write. instead
Yes.
of How I would do it. That
Exactly.
way, if we miss it, we get more points.
Bingo.
Showing.
Yes, the more work you show, the more points I'm able to give you out. So that's pretty much it. So we're going to do another example. Before we go there, questions on this one? So same concept for this next one. We're going to multiply and simplify. 15x plus 15 over 6x plus 30 times 3x plus 15 over 5x squared minus 5. So a couple things. Let's just deal with one thing at a time. So first dealing with the 15x plus 15, GCF.
15.
15. And we're left over with
X plus 1.
x plus 1. Let's go across while we're at it. So 3x plus 15, GCF. 3. And we're left with
X plus 5.
x plus 5. On the bottom, 6x plus 30, GCF.
6.
6, and we're left with
5.
x plus 5. 5x squared minus 5, GCF. 5.
X squared minus 1.
And we're left with x squared minus 1. Here, what about x squared minus 1? And a lot of people got on the test, for example, they got this part and then they just stopped.
Stop. Yeah.
Yeah, you got to keep going. So x squared minus 1, what do you notice?
It's a constant.
Yeah, their conjugates are going to be difference of 2 squares. Good. So I can break down x squared minus 1. I can factor it into x plus 1, x minus 1. X squared is x times x. 1's positive, 1's negative. 1 is 1 times 1. Again, it's those difference of squares. So the hard part's done. We factored everything separately. So now it's just putting it back all together. So multiplying straight across, I have 15 times x plus 1 times 3 times x plus 5 all over 6 times x plus 5 times 5 times x plus 1 times x minus 1. Now my favorite part. Let's see what can cancel. X plus 1's I see. X plus 5 can cancel. What else?
5 and 15.
15 and 5. I can take out a 5 from both of those. Seriously? And I'm left with 3 up top.
You read 3s.
1 on the bottom. My 3's are both up top though. So I can't cancel them out together. But what could I cancel out with a 3? 3 and 6. So I can take out a 3 from both of those. I'm left over with 1 up top and 2 on the bottom. So up top I'm left over with 3 times 1, which is 3. All over 2 times 1, which is 2 times x minus 1. So my final answer is 3. Yeah. My final answer is 3 all over 2 times x minus 1. How do we feel so far? If you know factoring stuff, how do you feel? Shouldn't be too bad. Just canceling out, which is the fun part. All right, so last multiplying one. Multiply and simplify. X squared minus 7x minus 18 all over 2x squared minus 162 times x squared plus 18x plus 81 all over 3 minus 5x. Yeah, it's just a lot. So it's really important to be really neat and organized with your work here. So what I'm going to do is I'm going to factor each one separately. So coming down here, x squared minus 7x, let me go down a little bit, x squared minus 7x minus 18. So we have no GCF. Our A value is 1, thankfully, because that'll help us out a lot. B is negative 7. C is negative 18. So two numbers that will multiply together to give us A times C, which is negative 18.
Negative 9 and 2.
And the same two numbers that'll add to give me B, which is negative 7, negative 9, and positive 2. Good. So negative 9 times 2 is negative 18. Negative 9 plus 2 is negative 7. Because A is 1, I can go straight to my factors of x minus 9 times x plus 2. So I'm just going to write that up here so that way everything's super neat and organized. So above x squared minus 7x minus 18, I can write x minus 9 times x plus 2. First one's done. Let's do the next one. X squared plus 18x plus 81. Again, no GCF. Again, A is 1, so that's good. B is 18. And C is 81. So two numbers that can multiply together to give us A times C, which is 81. And the same two numbers that could be added together to give us 18, which is B. 9 and 9. 9 times 9 is 81. 9 plus 9 is 18. Because A is 1, thankfully I can go straight to my factors of x plus 9 times x plus 9. So I know that's x plus 9 squared because it's written twice, but I want to see what factors can cancel, so I'm just going to write it all out, and if they both survive, then I'll put it back together as squared. So x plus 9 times x plus 9. So I'm going to leave it and write it out twice so that way I can see if what factors cancel and what don't. Going into our last two. 2x squared, good, minus 162. I have a GCF of 2 first. Factoring out that 2, we're left over with x squared minus 81. And then we have another difference of perfect squares, so bringing down that 2. X squared we know is x times x. One's positive, one's negative. 81 is 9 and 9. So we can factor that into 2 times x plus 9 times x minus 9. Our last one is 3 minus 5x. If you want to change around, you can, but I know there's nothing that has 3 and 5x in it, so it's not going to cancel out, so I'm just going to leave it because it's more work. So now putting everything together, multiplying across, we have x minus 9 times x plus 2 times x plus 9 times x plus 9 all over 2 times x plus 9 times x minus 9 times 3 minus 5x. The hard part's done. We can just now cancel and see whatever's left over. So x minus 9s go away. 1x plus 9 goes away. And that seems to be it. So up top, we're left over with x plus 2 times x plus 9 all over 2 times 3 minus 5x.
I shouldn't have to go even more into that.
Yep, no, that's it. No, none of the factors are the same, so nothing else can cancel, so that'll be our final answer.
Now, what is the next problem you saw up front?
So we did simplifying, we did multiplying. Our last thing we're going to do for this section is dividing. Before we go there, what questions, comments, or concerns do you have for me?
It looks like it's still going.
Okay, we'll try it. All right, so dividing rational expressions. So basically we're just dividing fractions. So same kind of concept. We're dividing and simplifying. 1/4 over 2/3. So 1/4 divided by 2/3. So I'm going to kind of emphasize that middle fraction bar. So again, fractions mean what? Add, subtract, multiply, or divide?
Divide.
Divide. So I can rewrite this as 1/4 divided by 2/3. That looks a little easier.
No, it doesn't.
Sorry. By the way, this is called a complex fraction. A fraction within a fraction is called a complex fraction. So I have 1/4 divided by 2/3. So whenever we are dividing fractions, you can either say multiply by the reciprocal, you can say keep it, change it, flip it, you could say KFC or something that I heard some people say because they just want me to be hungry. Yeah. I say stay, change, flip, but any of those things mean all the same thing. So stay, change, flip. Our first fraction is going to stay the same. We are going to change our operation from division to multiplication. And we are going to flip our second fraction. So stay the same, so 1/4. Changing from division to multiplication, flipping our fraction. So I now have 1/4 times 2/3. So now it's exactly like the previous problems. So that's our only little step that's different. So now we can multiply straight across. So 3 times 1 is 3. All over 4 times 2 is 8. 3 and 8 have no factors in common. So 3/8 is our final answer for that one. So that's our little division review. So same exact concept, but bringing it a little bit more to our speed. So let's go ahead. We're going to divide and simplify a plus b over ab divided by a squared minus b squared over 8a cubed b. So let's go ahead and let's stay, change, flip, or whatever you want to say. So our first fraction is going to stay the same. Our operation is going to change from division to multiplication. And we are going to flip that second fraction. So a plus b over ab now times 8a cubed b over a squared minus b squared. So a plus b. No GCF, nothing can factor, that one's fine. 8a cubed b, that's fine. ab, nothing we can do. A squared minus b squared. Difference of perfect square is good, so we can factor this down. A squared is a times a. One's positive, one's negative. B squared is b times b. So we have everything factored. So now multiplying straight across. A plus b times 8 times a cubed times b all over a times b times a plus b times A minus B. Again, I just like to write the multiplication sign in between each one, so that way it kind of separates it a little bit, and it's kind of easier for me to see what factors cancel. Do you have to do that? No, but it just kind of helps me, so that's the way I do it, so maybe it might help you too.
Do the boss.
Okay, sounds good, thanks. So now I can easily see what cancels. So A plus B. I see a B can go away on the top and the bottom. I have 3 A's up top. I have 1 A on the bottom. I can take out one of those A's. If I have 3 of them up top, how many is me left over if I'm taking one out? A squared. Squared. So let's see what's left over. I have 8 times that A squared left over up top, all over A minus B. Those are both A's, but they're not the same factor, so I can't cancel them out. So 8A squared all over A minus B is our final answer for that one. What questions do you have for me? If not, let's keep going. Last two for this section.
Probably for class.
Divide and simplify. We're going to try. A squared minus 5x minus 14 over 3x squared minus 147 divided by x squared plus 9x plus 14 over x squared plus 14x plus 49. So let's go ahead so we don't forget to say change flip. Let's go ahead and do that first. So our first fraction is going to stay the same. So x squared minus 5x minus 14 over 3x squared minus 147. Our operation's changing from division to multiplication. We're going to flip our second fraction. So x squared plus 14x plus 49 all over x squared plus 9x plus 14. So unfortunately, we had to factor each of these separately.
We have to factor in.
Yep.
Yep.
Alright, let's do it.
It's not that bad.
It's really not.
X squared minus 5x minus 14, GCF.
No.
Nope. But thankfully,
X 1, 7.
yep, A is 1, B is negative 5, C is negative 14. So two numbers that multiply together to give us A times C, which is negative 14. And the same two numbers that add together to give us negative 5, which is B. Negative 7 and positive 2. So negative 7 times positive 2 is negative 14. Negative 7 plus 2 is negative 5. Because A is 1, I can go straight to my factors of x minus 7 times x plus 2. So that one's done. Next one, x squared plus 14x plus 49. Again, no GCF. Our A value is 1.
X plus 2, X plus 7.
Perfect. B is 14. C is 7. No, sorry. 49. A is 1. B is 14. C is 49. So two numbers that multiply together to give me A times C, which is 49. And the same two numbers to add together to give me B, which is 14. 7 and 7. 7 times 7 is 49. 7 plus 7 is 14. Again, because A is 1, thankfully I can go straight to my factors of x plus 7 times x plus 7. So, again, just like a previous problem we've seen, I don't want to write it as x plus 7 squared because I want to see my factors. So I'm going to write it as x plus 7 times x plus 7. Two more. 3x squared, let me write it up here so save some room. 3x squared minus 147.
We're going to take out the 3.
Let's take out that 3 and we're left with
X squared minus 49.
x squared minus 49.
And the conjugate x plus 7 is 1.
Perfect. So x squared minus 49 is a difference of perfect squares, so it can be factored. X squared is x times x. One's positive, one's negative. 49 is 7 times 7. Last one. X squared plus 9x plus 14. No GCF. Our A value is 1, B is 9, C is 14. So two numbers that multiply together to give me A times C, which is 14. And the same two numbers to add together to give me B, which is 9. So 2 times 7 is 14. 2 plus 7 is 9. Because A is 1, I can go straight to my factors of x plus 2 times x plus 7. The hard part's done. You survived. Barely. Some of you. So that's all so far, just last test stuff. So, sound like I said last Tesla. Okay, so let's see what's left over. Up top, multiplying straight across, x minus 7 times x plus 2. Times x plus 7 times x plus 7 all over 3 times x plus 7 times x minus 7 times x plus 2 times x plus 7. Just putting it all together. So let's see what cancels out. X minus 7, x plus 2, x plus 7, and the other x plus 7. So what's left over? That's what. Wait, hold on, let me start over.
1/3.
What's left over up top? 1. On the bottom,
3.
3. So 1/3 is our final answer. So that whole crazy mess, and they left us with 1/3.
That's beautiful. That's a great question.
Good.
Having it like this big
Yeah.
answer. It's just a number.
Yeah,
Next one we're
just
doing
1/3.
polynomial.
So last one. Before we go there, questions for me. Before we go there, questions for me. So if you are good with last test stuff, which you should be, this should be an easy section. If you're not good with factoring, please, we're only going to factor more. So please come see me. All right, so last one for this section. Divide and simplify. 9 times, let me start over. Divide and simplify. 9b plus 27 over 2a plus 8 divided by ab minus 4b plus 3a minus 12 all over a squared minus 8a plus 16. Let's go ahead, so we don't forget, let's go ahead and stage change flip it. Our first fraction's staying the same. 9b plus 27 over 2a plus 8. Our operation's changing from division to multiplication. And we're going to flip our second fraction. So a squared minus 8a plus 16 all over ab minus 4b plus 3a minus 12. So exactly the same as the previous one. We're going to factor each one separately and then bring it all together. We're going to factor each one separately and then bring it all together. So 9b plus 27, GCF. 9. And we're left with b plus 3, so that's done. That's not too bad. Let's go over a squared minus 8a plus 16. Let's factor that. So there's no GCF. Nope. Our a value is 1, b is negative 8, c is 16. So two numbers that multiply together to give us a times c, which is 16, and the same two numbers to add together to give me b, which is negative 8.
Negative 4, negative 4.
Negative 4 and negative 4, perfect, thank you. Negative 4 times negative 4 is positive 16. Negative 4 plus negative 4 is negative 8. So because a is 1, thankfully I can go down to my factors of a minus 4 times a minus 4. Another thing, just because I was thinking about the test, and I think you didn't do it on purpose, obviously. You just did it on accident. But don't forget to write a's here. Our variable's a instead of x. Don't forget to write a's there. So a minus 4 times a minus 4. Again, I want to leave it written out twice so that I can see what factors cancel. Going down, 2a plus 8, GCF. 2. We're left with a plus 4. That one's done, so that's easy. Last one, ab minus 4b plus 3a minus 12.
Factoring by groups.
Good. For one, there's no GCF, but there's already 4 terms for us. We can go ahead and factor by grouping.
Take out B.
Going back and factoring by grouping. So let's group the first 2 and the last 2. Looking at our first 2 terms, ab minus 4b.
B.
You take out a b,
A minus 4.
and we're left over with a minus 4.
Take
Looking at our last 2 terms, 3a minus 12.
out a 3.
Take out a positive 3.
3.
And we're left with a minus 4. So b times a minus 4 plus 3 times a minus 4. We know we did it right because they both have a minus 4 in common. So that'll be one factor. What's our other factor?
B plus 3.
B plus 3. Whew, hard part's over. Now just putting it all together. So putting it all together, multiplying straight across. 9 times b plus 3 times a minus 4 times a minus 4 all over 2 times a plus 4 times a minus 4 times b plus 3. Make sure that, for example, b plus 3, those 2 things are being added together, so they're their own little like family, their own little factors, so don't forget to put parentheses around there. So seeing what can cancel out. B plus 3, a minus 4. That's it. That's an a minus 4, that's an a plus 4. They're not the same thing. So let's see, up top we're left over with 9 times a minus 4. On the bottom we're left over with 2 times a plus 4. No factors are in common, so that's going to be our final answer. And this is Module 7, Homework 1 notes.